Non-Euclidean Geometry by Roberto Bonola. Chapter 1. The Attempts to Prove Euclid's Parallel Postulate. Section 9. The Parallel Postulate during the Renaissance and the 17th century. J. Wallis, 1616 to 1703, abandoned the idea of equidistance employed without success by the preceding mathematicians and gave a new demonstration of the fifth postulate. He based his proof upon the axiom, to every figure there exists a similar figure of arbitrary magnitude. We now describe shortly how Wallis proceeds. Let A and B be two straight lines intersected at A and B by the transversal C, see figure 8. Let alpha and beta be the interior angles on the same side of C, such that alpha plus beta is less than two right angles. Through A, draw the straight line B' so that B and B' form with C equal corresponding angles. It is clear that B' will lie in the angle adjacent to alpha. Let the line B be now moved continuously along the segment AB, so that the angle which it makes with C remains always equal to beta. Before it reaches its final position, B', it must necessarily intersect A. In this way, a triangle A, B1, C1 is determined, with the angles at A and B1 respectively equal to alpha and beta. But by Wallis' hypothesis of the existence of similar figures upon AB, the side homologous to AB1, we must be able to construct a triangle ABC similar to the triangle AB1C1. This is equivalent to saying that the straight lines A and B must meet in a point, namely the third angular point of the triangle ABC, therefore, etc. Wallis then seeks to justify the new position he has taken up. He points out that Euclid, in postulating the existence of a circle of given center and given radius, Postulate 3, practically admits the principle of similarity for circles. But even although intuition would support this view, the idea of form, independent of the dimensions of the figure, constitutes a hypothesis which is certainly not more evident than the postulate of Euclid. We remark further that Wallis could more simply have assumed the existence of triangles with equal angles, or as we shall see below, of only two unequal triangles whose angles are correspondingly equal. Non-Euclidean Geometry, a critical and historical study of its development. This book was written by Roberto Bonola, professor in the University of Pavia. It was published by the Open Court Publishing Company, Chicago, 1912, and is now in the public domain. Read by Jim Renholt, with programming and illustrations by Jim Renholt, 2019. Thank you for listening.